Okay, so we're back. Math and chemistry continued. So now today we're going to learn about scientific notation. Scientific notation is just taking a large number, a super small number, and writing it in a more manageable form. So a condensed form of writing large or small numbers. The M is going to be a ones place, and then however many significant decimal, and then however many significant figures you need, times 10 to the whatever it needs to be. The only rules that M has to be is it has to be greater than or equal to 1, but less than 10. N must be a whole number. It can be positive or negative. If it's positive, that means it's a large number. If it's negative, it's going to be a super small number. We'll talk about that more in a second. So we find the M by moving decimal point over in the original number so that the left or right, there's only one non-zero number. So here we have 56 million. So I'm going to move it where my decimal is here. 1, 2, 3, 4, 5, 6, 7. So it was 7 places to the left. Here I'm going to go till, again, ones place. 1, 2, 3, 4. Here that's 4 places to the right. So this number will be negative and this number will be positive because this is a large number, this is a small number. So we find the N by counting the number of places you move the decimal and include the plus sign or the minus, or include the negative sign if needed. So if we move to the left, it's positive, or to the right, it's negative. So in our case earlier, we had 5.6 times 10 to the 7th. This would be 2 significant figures. I could add more by adding a 0 on this side if I needed it. But in this case, it's 2. Okay. Here, it's 3.099 times 10 to the minus 4th. I have 4 sig figs. And this 0 is significant because it is sandwiched in between 2 significant digits. Here it's understood as positive, so I know this is a large number. Here is negative, so it is a small number. So let's look. When we talked about adding and subtracting with scientific notation, if they have the same exponent, just add or subtract the main number values and keep the exponent. Exponents may need to be shifted if the main number drops below 1 or above 10. If they don't have the same exponent, change them so they do and convert back to the regular notation. So notice these do not have the same exponents. So we change it back to standard notation and then our answer. We could also, since it's only 1 apart, if we needed to, we could add it as 0.5 times 10 to the 8th, but that's not good practice. Okay, here's another one, 3 times 10 to the 6th and 5 times 10 to the 2nd. And here we go. But this number would not be correct because I only need 1 significant figure. So it would be 3 times 10 to the 6th. Okay. Here again, I would only need 1 significant figure if this was not a conversion or accepted. So when we multiply, we're going to multiply the main number values. And then the exponents are added for multiplication, just like you learned in math. And I do want you to get to where you can do this mental math. And we will have mental math Mondays where you're learning how to do it. So we're going to multiply these two numbers together first and then add the exponents. So I know that my answer should be somewhere around -7. Okay, so 2.3 times 8.6, it turns out to be 19.78. So I'm going to have to move that decimal one more place. So my answer is 1.978 times 10 to the minus 6th, okay, which is close to what I was expecting. Here's 2 significant figures, so this would actually end up being 2.0 times 10 to the minus 6th. I did not account for significant figures when I worked these problems out. But since you've learned that already, it's best practice to continue learning them. Division, again, just like in math, we're going to subtract exponents, divide the main numbers, and subtract the exponents. So 7 minus 3 is 4, so our answer should be somewhere around times 10 to the 4th. And sure enough, it's times 10 to the 3rd. Again, watch those significant figures. That shows only 2, so our answer should be 8.7. Here's our calculator. So to put it into scientific notation, you're going to use the second button and the EE. So the second, that does not look like an N, does it? So the times 10 in our calculator is actually going to be gotten by hitting the EE button, which is the second and the yellow button there. Keep scratching over it. Okay, so you're going to hit this first and then the EE button second. So the way we would write, you would put it in the calculator 7.2 and then you would type in second, then the EE button 7. And what that means is 7.2 times 10 to the 7th. Okay, and you can see it gives it to us here in scientific notation. If I need to put it in scientific notation, I can push second and then science, and then all numbers would be in scientific notation. That's where we're going to actually be. Then this fix button, so you'd hit second fix to set the decimals. Okay, I wouldn't set it for anything less than 4. And then you're going to hit second science, and you'll see you'll have to select science to put in scientific notation. Okay, sorry, I don't have a picture of that. I'll show you. Of course, I'll show you in class. So I only will allow you to do that after I can see that you have mastered how to do it in your head first. All right, so let's talk about the metric system real quick. These are the metric units you need to know in chemistry. Amps are more physics, but I do need you to know meter, kilogram, second, Kelvin, mole, and then luminous is actually physics too. So A and C, D we won't use those much in chemistry, but we will use amount as a mole, temperature in Kelvin, times seconds, mass, kilograms, length, and then of course I left out, volume, which is the liter. Here are your prefixes. You don't have to know all of these prefixes, but I do expect you to know the conversion 10 to the 3rd for kilo, the centi, and the milli. Those are the ones we'll use the most. Okay, common standard from standard international to metric, 1 inch is 2.54 centimeters. You need to know that. 1 kilogram is 2.20 pounds. And then most of the rest you'll be given at some point, but it won't hurt you to know those. So temperature conversions, because Lord have mercy, this Fahrenheit is a hot mess. Fahrenheit is going to be 9/5 of Celsius plus 32. So then to get Celsius is 5/9 times Fahrenheit minus 32. How ugly is that? That's why in chemistry we like Kelvin. Absolute zero is 0 K. 0 degrees Celsius is 273.15 Kelvin. Super easy conversion, but you will need to know how to convert between all three of them. Okay, so for instance, water boils at 100 degrees Celsius, 212 degrees Fahrenheit. We're going to add 273.15 to 100, and that's how we get Kelvin. You have to go to Celsius before you can get to Kelvin. Room temperature, you do need to know that room temperature is about 20 degrees Celsius, and then of course you can convert. And then absolute zero, we'll learn more about that next semester, and we have never really actually attained absolute zero. We have gotten helium to become a liquid, but that's at quite cold. So let's look at How to convert. What is 32 degrees Fahrenheit in Kelvin? Well, we know that that's 0 degrees Celsius, which is 273.15. But how did I get that? So we're going to go Fahrenheit to Celsius, and then from Celsius to Kelvin, which is basically what we did up there. Okay. All right. We have one more. So what is 298 K in Fahrenheit? Again, we've got to go this direction first. We got to get to degrees Celsius. So 298 minus the standard conversion, 273.15 equals 25 degrees Celsius. Then I'm going to take that number, times it by 9/5 and add 32. Geez, what a mess. That's why we don't like Fahrenheit in science. We won't worry about, we won't go degrees Celsius. Sorry, where am I at? We won't go from degrees Fahrenheit to degrees Celsius more than this unit. Everything we'll ever take is going to be in degrees Celsius, and we'll go to Kelvin. And the reason we go to Kelvin is that's what our standard temperature and pressure, that's the way, the measure of the motion of the particles, and we'll learn about that later as well. If you have any questions, not to worry, we'll talk about it in class tomorrow.